Okay, so let's see the actual execution of this through the simulator by OceanSoft. So what I'm first going to do is I'm going to load the hex file corresponding to my interrupt program. So which is, if you recollect, in the class we said that I can write a program in Jubin simulator and then save the program as a hex file, and the hex file I can load inside my OceanSoft 8085 simulator environment and I can still run my program. So I'm going to load the hex file. Okay. So my hex file has been loaded. I am going to start simulation. Okay. So obviously the first instruction it is saying is going to be the jump 1000, because the first instruction at location 0000 is going to be what? Jump to location 1000, and at location 1000 is my main program. So now let's see the actual running. So I'm going to do step by step. So I'm going to click on step by step. So it has executed the first instruction, which is jump to 1000. Okay, so at 1000, what is the next instruction? It is expecting from my main program? Load the stack pointer. I'm again going to step. Okay, then I'm going to continue stepping through my program. So next instruction is move 99 into C. So C has got the value. C has now got the value 99. Can go step 98 goes to D, so which means we can also see it here 98 has gone to D, or we can see it here that D has value 98, and so on. I'm going to step through step. Okay, now we are going to stop here. Remember that I am moving a 08 into the value A. So currently the value of A is 08, so which means the instruction after this is going to be the sim instruction. And the sim instruction is going to do what? It is basically going to unmask all my interrupts. Okay, so I'm going to step. So sim instruction has executed. Now I'm going to enable all my interrupts through the EI instruction. I hit a step. As soon as I hit the EI instruction, you will see that these buttons, okay, which are basically my interrupt buttons, have now suddenly become highlighted, or they have become enabled, which means if I wish I can actually click on this button now and it is going to generate an interrupt for me. Okay. But I'm not going to do that. I'm going to just go through the main loop that we have, the loop which is a function of variable B. So I'm going to step. I'm loading FF value in B. Okay, I'm going to hit a step. It is going to decrement the value of B. Okay. So B has decremented from FF to FE. Okay. I'm going to hit a step. It is going to jump, if not 0, back to decrement B. Okay, and it is going to now, if I hit step again and again, okay, it is going to continuously keep decrementing the value of B. So you can see that the value of B is now decrementing over here. This is the value of B it is displaying, and if I continue keep on stepping, it is basically going through a for loop, okay, where the value of B is being decremented. Okay, so let's say currently the value of B is EF. Okay, now I am going to hit my interrupt called RST 6.5. So as soon as I click RST 6.5, it is going to take the interrupt. So it has interpreted, the processor has interpreted that I have pressed RST 6.5, and hence I am supposed to go to which particular PC location? 0034. Why? Because 0034 is the vector address of RST 6.5. Now as soon as I go to 0034, the first instruction that it will see is going to be the jump instruction, jump to 2000, and jump to 2000 means I am going to jump to my interrupt subroutine over here. So let's see if it does that. Okay. So I am back here, I am going to hit a step. So the next instruction that it took from 0034 was jump to location 2000. And at location 2000, the first instruction in my instruction subroutine is going to be push PSW. So I'm going to step, it has done push PSW, it has saved the value of register A and your flags, it has saved onto the stack. Remember that we had initialized the stack pointer to FFFF. Okay. Currently the stack pointer is at some other location, which means we have started utilizing our stack, obviously. Step, step, step. So I'm doing all the pushing. Okay. Now here comes my actual dummy interrupt subroutine, the task in the interrupt subroutine. I am changing the values of B, C, D and E as opposed to what were their values earlier. Okay, so I am deliberately changing their values. Okay. Here I am changing the value of B to a 0. Remember that when we left for the interrupt subroutine, when I had pressed RST 6.5, before leaving, what was the value of B that was there? It was EF. Now currently the value of B that I have loaded inside my interrupt subroutine is 00, which means it has disturbed the value of B. But luckily you will see that I am going to pop all the values. I am going to step, step, step. Now as soon as the value of B has been popped, you see that B has actually been restored back to its original value. This is the value that B had before I left for the interrupt subroutine. I am going to now hit a step. This is going to pop the value of PSW. I am going to hit a step. Okay. Now it is enabling my interrupts again. Okay. And I am going to hit a step. It shows now return. Where is it eventually going to return to? It has to return back to where it had left. So for example, the last instruction that we had before we left was the decrement instruction. So which means now if you look at this diagram, the instruction that I had last executed was decrement B, after which it left to my instruction subroutine, which means now when I hit the return from here, it is going to go back to this particular instruction which was after my decrement B instruction, which means it is supposed to go back to this jump if not 0 to L1. So let's see if it does that. I'm going to step and it went back to jump if not 0, and now again it is going to continue doing the decrement B continuously if I hit a step. So now the value of B has started again decrementing. So this shows you an example of where you can use the hardware buttons that you have, the hardware signals which act as interrupts, and this example tells you that you can use the vectored addresses for those interrupts, and where you will have to write a jump to go to your main interrupt subroutine, do some task inside your interrupt subroutine, and then once your interrupt subroutine ends, you are going to jump back to the place where you had left.